Okay, so remember, the product property tells us that if we have two logarithms adding each other, we can condense it this way. The quotient rule tells us that if a logarithm has a quotient inside its argument, this can be separated as the subtraction of two logarithms. And lastly, the power rule tells us the relationship between an argument that has a power, and it tells us that this power can be removed from the argument as a number multiplying the logarithm. Also, remember the order in which you can apply these properties is always starting by the power rule. Why? Because as in hierarchy of operations, you first do the powers, then you do the product of quotients, okay? So let's start with this example. In this example, I have a bunch of logarithms, and notice that two of them have numbers multiplying outside the logarithm, meaning that I will have to apply the power property first. So this is logarithm base e of 2 to the power of 3 plus logarithm base e to the of 3 to the power of 2 minus the logarithm base e of 5. This can be simplified as logarithm of 8 plus logarithm of 9 minus logarithm of 5. Now, apply the following properties however you like. For example, I have two logarithms adding each other, so I can simplify them by using the product property. So this is going to be condensated as logarithm of 8 times 9, and 8 times 9 is 72. Minus the existing logarithm. And this is a subtraction, meaning that I can use the quotient property to simplify this to the expression logarithm base e of 72 over 5. This cannot be simplified any further, so this is the end. In my next exercise, notice that my logarithms don't have any number multiplying them. And I'm also going to show you that you can start applying the properties, the quotient and product properties in the order you like. So first I'm going to start with this 2 instead. So this is logarithm base 5 of 150 plus this subtraction, because these logarithms are subtracting each other, this can be rewritten as the quotient of the argument. So this is logarithm base 5 of 1/2 over 3. How to simplify this? This is a sandwich law. So you have 1/2 over 3. Put the denominator of 3. So this is harmónica abajo, breadth upwards. So this can be simplified as logarithm base 5 of 1/6. And this logarithm remains the same. Now I have two logarithms adding each other. So I can apply the product property to simplify this. Logarithm base 5 of 150 times 1/6. And this is the same as logarithm base 5 of 150 over 6. And this is the same as logarithm base 5 of, you can do the division, 5 over 150 over 6 is 2 times 30, 25. So this is logarithm base 5 of 25. And this obviously can be simplified further by saying 5 to what power gives you 25? And the answer is 2. So this is the last simplification. Let's do this one. So what happens here? I have two logarithms with a coefficient multiplying them. So we can plug those values inside the logarithm. And I'm going to show you how to do this right now. So first thing, I have a -2 multiplying my logarithm. So I'm going to plug it completely inside my logarithm, like this. And then logarithm base 7 of 2 to the power of 3. Now, I'm going to simplify this by logarithm base 7 of 1 over 25 plus logarithm base 7 of 8. Next, the property I can use because we have two logarithms adding each other, this is logarithm base 7 of the product of 125 times 8, and this is 8 over 25. This cannot be simplified any further because there is no way that 7